Hello YouTube, De-bodgery here. Welcome to EV Components Review. Ignore that stuff. That's a completely separate thing. This is a teardown of a Hirschmann Throttle. So these are made in Austria, designed in Austria, something like that. They don't say anywhere on them where they are made, but I can tell you that they are ridiculously over-engineered. There's a little sticker on the side there, but as you can see, it doesn't say made anywhere either. There is a single place inside the plastic that has got a stamping on it, sort of like that, but once again, it doesn't tell you where it's made. Anyway, so first things first is thank you, Mike from Watt Wheels in New Jersey, for sending me these Hirschmann throttles. The idea was I would take them apart and figure out why it is that they have 6 wires rather than 3. Mike has been using one of these for a while, and he figured out that the black wire and the red wire and the violet wire, that is Hall. So he didn't figure out what these other 3 wires right here are, and so that was part of the reason why he sent me these, and makes a good opportunity to take something else apart. And as you know, I do teardown videos. I have been building EVs myself since 2015. Went to school for electrical engineering. I've worked for many years in electronic repair. Yeah, electronics is kind of my thing anyway. So anyway, yeah, he sent me a couple of these things to take one of them apart and try one out as well. Just to see how I like them, things like that. Anyway, this plastic is something tough. I don't know what it is. There's no stampings like inside anywhere or on the outside of it to say that it's like polyvinyl chloride or whatever. What I can tell you is that it's a fairly tough plastic. You know, like you can see me squishing it a little bit, but it's quite resilient. It doesn't break easy. This isn't brittle like, say, ABS plastic is. It's a very, very tough and resilient and slightly flexible stuff. I'm pretty sure that if you go down and you smash your throttle on a rock or something, you'll probably just get back up again and go like, oh, that's all right, and keep on going. Because the plastics used in here are quite solid. The shroud around the wires, so here is the one that used to be on there. This is some kind of a fairly thick wall plastic. So the wires are pretty well protected too. Yeah, everything about this is pretty thoroughly engineered to be resilient. The spring inside here is pretty strong, so most of the time, like on all your Chinese, Hall throttles or twist throttles of any kind, the springs tend to be pretty weak. You can almost like roll your hand backwards and get them to twist. Whereas this one here, you gotta grip it, and admittedly, there's not a grip on here. And I guess I should mention that right now. So this diameter is 1 inch, so you're going to need like motorcycle grips to slide on here. Your typical 7/8 stuff, which is what the inside diameter is, that obviously won't slide onto here. But anyway, when you twist this thing, you've got to hold on to it. The spring has got some good command to it, so yeah, you're not going to just twist that by accident. You can't just slide your hand on it like a lot of the Chinese ones because their springs are so weak. You got to actually turn it. So yeah, it's got good command. It feels good in your hand. There's a little bit of wobble right here, so let's see if I can show that. Yeah, you can kind of see it right there. But once you put this on your handlebars, that's going to be completely gone because any motion that's in here is going to be constrained around the handlebar. So I doubt you'll even notice that's there after that. So general build quality is pretty good. Can't really complain about that. I'm pretty sure this is going to be a pretty solid throttle. As far as like repair is concerned, well, you can look at here and just get a quick assessment that that's going to be a pain in the neck, and it is. So Hirschmann does not, flat out, does not want you to get in their throttles. And in fact, let me tell you a little bit of story about these things before I even get into that. I emailed them. I've had these throttles in my possession several hours because I wanted to know what the heck is 6 wires doing on a Hall throttle. And so for the throttles, there is a guy listed there. His email address is listed there, and it says, contact me for sales questions and support. So I emailed them, and within a minute, I got an auto response email back saying, "Hey, I'm going to be out until hell freezes over. Contact my coworker Joe." So, and Joe's email is listed in that auto response back. So I emailed Joe, and a minute later, I get an auto response back. "Hey, I'm going to be out until hell freezes over. Contact my coworker Jane." So anyway, Jane's email is there, so I emailed Jane. And same email again. A minute after I send, I get an auto response back. "Hey, I'm going to be out until hell freezes over. Please contact my coworker Jill." I'm making up names, obviously. But so then I contact or email Jill with the exact same thing that I did the other 3 people, and have never gotten an auto response email back. In fact, I've gotten no response whatsoever. So 4 out of 4 emails sent to talk to somebody about what the heck are 6 wires doing in a Hall throttle, and I've gotten nowhere. Mike from Watt Wheels, he has also emailed them and had similar high success rates. He did talk to one person over there about buying a bunch of these throttles, and that person basically said, "So are you an OEM? Are you building motorcycles or something?" And he goes, "No, I just want to have them for resale." And they wouldn't talk to him anymore. They pretty much don't want to deal with anybody unless you are a builder, or rather an OEM, large builder kind of a thing, like a Zero Motorcycles or something, I guess. Anyway, so good luck. You probably will get about as much support out of them as Mike or myself has. All right, so twisting it backwards, you get about 90 degrees worth of rotation, and there's a little secret forward twist as well. So I don't know how this shows up on camera. Yeah, you can kind of like see a little mark right there. Let me twist this forward. You can see it twist forward several degrees. Well, on the output on here, on this connector, you can actually measure what this position is right now, and then when you twist it forward, the voltage drops just a little bit more, like another 0.3 or 0.4 volts. So in your controller, you could set this right here being 0 throttle, right? And doing this right here, you could set that to be go into reverse, just creep along, I suppose. Otherwise, I don't know what this is here for. But yet, you've got more throttle position right there. Just a couple degrees of rotation. And this is deliberate. That's supposed to be in there. That's not an accident, and I'll show you that. So let's get into taking this thing apart, because that's kind of next, and that'll get to that little bit of throttle position. So right here, you can see one of them. Yeah, it's a 6-lobed screw head, and there's another one right there. So these screws, they have flats on those lobes, so you can tighten the screws. But then they have slopes, so that if you try to take the screws back out again, your tool will just simply slide up those slopes, and you won't take the screws out. So why you need a security screw on a throttle is an absolute mystery to me, but Hirschmann thinks you do. So yeah, you've got 2 of them. After fiddling with those for a while, I finally gave up and said, you know what, screw those screws, let's drill them out. And so I did, and I picked a 3.5 millimeter drill bit just arbitrarily, and conveniently that was the same diameter as the screw shank, and so I drilled right out the middle of the screw head, and the head just went plink, fell right off. Did that to the other screw, and then I was able to take this thing apart. So these 2 pieces of plastic were screwed together like that, and there was a screw here and here, obviously, and once those 2 screws are out, they just came right apart. The ends of the screws were obviously threaded down in those 2 holes and sticking up about that much, enough to penetrate through here. So I was able to put pliers on them and just undo the screws, and that was that. So yeah, I can replace those screws with, like, say, Phillips heads or Allen head or something like that, like Hirschmann should have done to begin with. But yeah. Anyway, yeah, they kind of over-engineered it for sure. Let's talk about this part here. So the spring is nice and stout. Like I said, you can't accidentally roll this backwards like you can with the really weak springs and most of your Chinese twist throttles. This one requires some command. You got to actually grip it and turn it with a little bit of effort to make it turn. So you're not going to accidentally turn your throttle. you're going to have to actually grab the thing and turn it to make it go. So it's got nice feel to it. You know, feels good and solid in your hands. It's got good return. You know, when you let go of it, it pops right back. It's got good return on it. So definitely like all those aspects of it. Inside here, so I talked about that little bit of motion forward. Well, there's this little pin right here, or piston, and come on, camera, focus. There we go. And that spring right there, which is actually much stiffer than that one. So when you do twist this forward, you have to twist it. You have to deliberately twist it forward. You're not going to do that by accident. And so when I push on this little piston or pin right there, you can see me moving it. That's what you're getting from right here and twisting it forward. That little bit of motion right there is that spring compressing that little pin pushing it in. So you get a couple degrees worth of rotation out of it. Wherever it is, that little plastic cover used to go right over top of there, and that is your magnet. So the magnet is almost 180 degrees of rotation on here. You know, that's a lot of magnet. And yet when you turn this, you only get about 90 degrees worth of rotation. So I don't know why they put such a big magnet in there. That's kind of overkill. So I have several throttles I've taken apart. You know, they broke, something like that, or they were just pieces of cheap steaming crap, something along those lines. And so I have the magnets out of several cheap Chinese throttles, and that's like the biggest one that I have from one of those. And as you can see, it's minuscule in comparison to the one inside this Hirschmann throttle. This is literally a 6mm wide magnet, 6 millimeters tall, and nearly 180 degrees worth of rotation. Whereas this little magnet right here is more along the lines of, say, like 80 or 90 degrees worth of rotation, and of course, you know, a lot smaller. And that's the biggest one I have. So yeah, pretty significant overkill on the magnet. Everything else is overkill, over-engineered as well. You have this little clamping mechanism that's inside there. So where's that piece? So this right here. So there's a little pin sticking up right there, and it captures this little clamping ring right there. Yeah, never seen that on a throttle before either. And then add to that, you get a 4mm shoulder bolt. Not just a 4mm bolt, a shoulder bolt. I mean, they kind of went overboard with the engineering with some of this stuff. You don't ever need this level of fasteners and things like that. You know, these little clamping rings are pretty simple, pretty straightforward. And they went to a shoulder bolt. They went to pentalobe security screws. Yeah, they went a little overboard on the engineering. You know, giant magnet in there making up nearly 180 degrees of rotation. This little springy compression thingy for a little bit of reverse throttle, I guess. Yeah, they really went overboard. But, you know, hey, it's pretty well built. I seriously doubt you ever break the thing, mechanically speaking. Then you get to this right here. So here's the little board, and it was buried down inside here. And you can see this little steel piece inside here. That's steel right there. And so I guess if you were to take a hit right here with a rock or a branch or something like that, the chances of you smashing this board is pretty negligible, because it's literally inside a little steel shield, and then on top of that, it's buried in hard potting. So the chances of you ever damaging this board under normal conditions is negligibly low. I guess if you threw it in a fire, you would probably burn it up. But normal kind of use situations, ride hard, you know, bash into trees and things, I doubt you're ever going to damage this throttle from that kind of activity. It would fail from something else, but not from physical trauma. Because all this plastic here is quite overkill, and then it's got this steel shield on top of all of that. All right, so let's talk about this board. So the first thing I want to show you is the back side. You can see how the wires are pulled away. That's because I was tugging on these to get this board out of here. So it fits into little slots inside here. I don't know why they show up, probably not hardly at all. Yeah, you can kind of see them in there. Yeah, little slots right there and there. So it sits in those, and of course everything was potted. So I was trying to dig out all the potting from there, and also trying to free it from those two slots because there was potting in all those too, and I was tugging on the wires to do that, and I was also prying on the edges of the board, and so I scratched it up. But if the camera will focus, come on, focus right here. There we go. But those wires, they were, you can see where the solder ends. The insulation was literally right there where the solder ends. So whoever it was that did the solder work on here and cut the wire lengths, they did them exactly right. Attention to detail here is just epic. All right, so you can see how it's kind of shiny on the back. And then you can see like little silver solder pads on there. So those are for diagnostics or programming or whatever. But the entire back side of this board, like you can see there, bare copper, this is actually a ground plane on here, an RF shield on the back side of this little dinky board for your throttle. Yeah, they put a ground plane, an RF shield, on the back side of this thing. This is a throttle. All right, so let me flip this thing over. And things just get more silly after that with the level of over-engineering. So this little chip right here, this little 16-pin IC on there, let me wake up my computer. It went to sleep on me. There we go. So that little chip, that is an MLX03 or 90360. It's from a company called Melexis, Melexis. There are two versions of this little guy. One version is just a single XYZ axis sensor, and the other one is a dual XYZ axis sensor. This is the dual one, so you have redundancy in here. Why you need X, Y, and Z axis for a throttle is beyond me. And so let me talk about just that little bit real briefly. So this orientation, that's X, that's Y, and that is Z. And you've got two of those in here. And it gets even sillier, or more over-engineered. So every single one of those things is two separate chips inside here. They have own independent voltage pins, own independent input and output pins. You just simply got two of the same ICs in the same package. Each one has a digital signal processor. It has flash memory in it. It has RAM, and it has a CPU inside there, ×2, inside that little thing. And this is for your throttle. When I looked up the data sheet, I went, you've got to be kidding. If that's not overkill, I don't know what is. And it's not just one. Keep in mind, there's two of those inside here. So, yeah, ridiculous amount of complexity for a hall throttle. All right, so my assumption, because I don't know this as fact, because I haven't bothered trying to pin anything out yet, is those three wires, you know, the red, black, and violet, they go to, like, say, sensor number 1, and those go to sensor number 2. At least that's my guess at the moment, but I honestly don't know that. And that's only the Y-axis on here, not X and not Z. So overkill by a lot, ×2, yeah. So anyway, hope to help some folks out. Enjoy. That was a bit of an interesting teardown. Definitely took time to take that thing apart.